Laboratoire d'intégration de l'écologie urbaine with colleagues in Montreal, where we have been working for almost 10 years with cities of Montreal and Quebec to try to improve the scientific basis for decisions that are made on green infrastructure in these cities. There is a lot of work being done to improve, to augment the presence of green infrastructure, but how is it functioning? That's what we're trying to get at, and especially from the angle of soils, because as I will show, it's often a bit a dimension that's neglected. I also work with a chair that's financed by the City of Quebec, and we are interested in, again, infrastructure around trees, what is affecting their survival, including soil quality. So with the chair, I'm working mostly with Janani Sibiraja, who is a relatively new prof at the Faculty of Forestry, who is now head of this chair on the urban forest. And with LIEU, with our Laboratoir in Montreal, working with Elise Beauregard, Vincent Poirier, who is a prof at UCAT, Antonius Petro, who has done his master's with our group. So just to thank and acknowledge these colleagues before we start. In urban environments, there's a lot with this multiplication of green infrastructure and interest. How can we better, we're interested in how can we better manage this capital by increasing biodiversity? And one of the big questions for cities is how can we reduce the costs of maintenance? But that may be difficult to, while you're multiplying green services, reduce maintenance. We can talk about this at the end, but it's one of their big problems. We need to start thinking more about how this green infrastructure interacts with human health and improve the maintenance or the pérennité, en français, pérennité. How do these infrastructures are they sustained in time? Because while we're multiplying all these surfaces, are we taking care of them? And is the vegetation surviving for the long term? And these are still big questions because a lot of this green infrastructure is fairly recent, so we don't have good ideas about how it's going to perform in the long term. So our group is trying to increase our knowledge about the ecological functioning of these green spaces and also their services, and especially looking at the soils, the underground dimension. As I mentioned to begin with, there's a lot of, the soil hasn't been well considered in cities, and even when we look at the personnel in place, there aren't personnel who really know soils very well. And maybe this has to change over time, that we hire people that have a good knowledge of soil plant interactions. Once we start seeing problems, then people say, oh, okay, so what's the trees dying? And then they may start to think about the soil, but it's not one of the first questions that they ask. But we are supposed to, by law, have indicators of that show that we're developing infrastructure that can endure in the long term. And so we need indicators, criteria and indicators related to the performance and also including soil quality. And I think you probably all are aware of some of these services related to urban soils, nutrient cycling, water infiltration, soil biodiversity, to also block the presence of invasive plants, reduce tree mortality, reduce, and this is something we have to think about more, the importing soils, either black soil from wetlands or mineral soil that's good agricultural soil to support what we're doing in cities. Maintain cooling and reduce urban heat islands, reduce emissions, and also, if we can, sequester carbon in these soils, though it's not that evident. So our approach is really to test experimentally different approaches towards finding more the practices that will help our infrastructures endure in the time. So we can try to increase at the same time with these approaches, increase biodiversity, use more adapted and local plants, look at the functionality above and below ground interactions of the plants, and some, as you can imagine, in urban conditions, one of the things that's not happening that happens in natural ecosystems is the return of organic matter to the soil. So how can we start doing that more naturally in cities so that there's this return of nutrients and recycling of nutrients to improve soil fertility? So today I'll take a synthesis of 3 projects that we've been working on over the last 5 years or so. One was with Montreal called Lola. What are the lessons from this? Another one in Quebec City, I Love. What are the lessons? And just look at some of the projects we did just this last summer, trying to evaluate how different infrastructures are performing and enduring, and look at some of the better examples in Quebec City of the infrastructures that have been implanted in the last several years. So for the project first, the Lola, which was with Montreal, one of the reoccurring concerns of the city was high maintenance costs, vegetation stress and death, so loss of plants and low diversity, especially the areas, as you can imagine, in the middle of boulevards. There often is this nice strip of green with, now we're starting to put in trees, but maintaining and making sure that this vegetation functions is really difficult because of the stress with the two traffic lanes at each side of these corridors. So they're looking with this project, are there some new things that we can try to have a better performance of our vegetation, reduce maintenance, find plants that are resistant to these stresses, and try to reduce maintenance and problems over time. So also, and of course, the solutions that you propose need to be acceptable to the residents that live around as well. So it's again another dimension that we need to include more, and also try to include even the residents in the planning and in maybe even the maintenance of the.
Oh my God, oh my God.
Yes, yes. So what we did a few things that were different. We were comparing our establishment of this infrastructure also with just leaving wood chips, which is frequently done around the trees, or just comparing to lawn to turf. And we used 2 techniques to establish either transplants, which is the most common technique, transplanting from 1 or 2 gallon pots into the soil. But we also were testing direct seeding, which could be interesting because it takes out all of the carbon imprint associated with transport, with growing the transplants. And it worked, as you can see on the right below, it worked quite well for especially certain plants. And that was what we were trying to do, selected plants that would work. So you can see the nice thick vegetation that has come in after seeding. And at the end of the season, again, you can see with the flowering that it looks good. It's managed to block out areas of the soil that could be invaded. So that's what we're aiming for, is to have this really thick cover by the first growing season. One of the main things in this I want to take away from this project that made us think and made the cities think for the future was the soil quality. So what we did was we looked at the soil at the beginning of the experiment before we implanted anything. And then we looked at the carbon that was accumulated at the end of 2 growing seasons in the biomass, above ground biomass, the litter, the roots, and in the soil from 0 to 30 centimeters. We were trying to see if even after 2 seasons, can we make some gains in carbon? Are there certain species that would help us gain more rapidly carbon in the soil and above ground? And how does the soil fertility look like after the 2 seasons of growth? And to our surprise, because we thought naively that we would be especially accumulating carbon, because these are bare soils, mineral soils with some high organic matter incorporated. But what we found over the 2 seasons was actually we were losing carbon, even considering the above ground biomass. So to the left, you can see this was in the smaller tree pits, and there was some minor accumulation. And again, it did vary with the species, ranging from aster here, milkweed, chicory, Deschancia, echinacea, rudbeckia, and the famous wood chips here were losing the most carbon in that case. So there was a difference between species, and the small pits could accumulate some carbon. The large tree pits were losing carbon all across the board. The big square pits that were used mostly for perennials were also losing carbon across the board. And the boulevards, in the middle of the boulevards, the strip, were also losing carbon. So we were starting to think like, whoa, this doesn't look good. We're just emitting carbon, even though we're planting, we have plants in there established with roots over 2 seasons, and we're just losing carbon. So what was the reason? What we found were 2 main factors. One was the very high organic matter content of these soils at the beginning. They're really, you can see the stalks here, and the higher the carbon in this case, the more that you lose. The higher the carbon at the beginning, the more was lost over the 2 seasons. And the other factor was exposure to sun. So that means higher temperature. So these, the ones that were exposed to more sun were losing a lot of carbon. Ones that had less sun exposure were gaining some carbon. So you can see how microclimates have this big effect in urban plantings. And the reason that we are hypothesizing that we're losing this carbon, it's being emitted, we're putting in a sand matrix, dominated 85% sand, very low fines, but it's the fines that are able to retain carbon, not sand. Sand doesn't have the kind of surfaces that will stock carbon, that will react with the carbon in the soil. So in this kind of environment where you have high temperature, high organic matter, a lot of exposure to sun, we're just burning off the carbon in most cases, except in some microclimates. So what should we do about this? Should we increase in the norms that are demanded by the city? Should we increase the concentration of silt and clay? Should we work with a different kind of surface than the wood chips? How can we increase using different species, maybe the below ground allocation, and so the carbon in the soil? So we're going to have to look at these a longer term. We want to go back to the same experiment and look to see if we're still losing carbon. We haven't done it yet, maybe next year. So that's one of our questions. But in both Quebec City and Montreal, we have the mixes that are used by the engineers, the norms or the that are used require this high level of sand, which is normal because they want a very good drainage. But at the same time, we have this very high organic matter here, from 4 to 8 to 8 to 12, and in Quebec, Montreal, I mean, it's even 10 to 15% organic matter. That's a huge amount, especially for a soil that can't hold the organic matter. And this type 2 mix, both for Quebec and Montreal, it is used for perennials and for, say, long-term tree pits with a nice mix of species. But we need to think of what this is really doing and what we should do. And that's part of what is actually now, because of our work, there's a reflection going on about the texture of soil that's being used and the need to check or validate the texture that's being delivered. There seems to be now, when we started to check a few places, especially Montreal, soils being delivered that does not even meet the minimum requirements for the fine textures, the silt and clay that is there. So that's undergoing possible change in norms because of this work. And that's what we'd like to do. One possible strategy to reduce emissions from tree pits is the use of biochar, which I'm sure many of you have heard about. We have a new project with our urban chair that in 4 cities, Toronto, Quebec, Montreal, and Edmonton, will look at how biochar incorporated into the tree pits might help to reduce emissions and incorporated into different layers in the tree pits. One of the researchers, Sean Thomas, also found that waste disposal in cities, such as all the trees that we're cutting down because of the ash dieback, these can be methane hotspots. And we have to look at also the way waste is being handled, and perhaps biochar also can be a response to this problem. So we'll look at the emissions and we'll look at also tree response. So biochar has shown in many agricultural conditions to be a very good amendment for soils to reduce gas emissions. Though I've just seen some work in northern environments in Scandinavia that they didn't find this same effect of reducing CO2 emissions. So we have to look at in different contexts as well. And it can increase plant resilience because it does help to hold water in the soil. It also helps to retain nutrients, sequester carbon, and help to soil aggregation. So this is a possible response to help urban soils have a better quality. Okay, I'll go on to our second project I love with the Quebec City, and this will go fairly quickly, where we looked at, over the past 5 years, some of the different infrastructure implantation and how are they doing now 5 years after implantation, and the responses were fairly variable, but fairly good overall. One thing that we noticed was fairly low biodiversity. And so you can see here, it looks quite nice. Trees are doing well. And we have these nice both shrubs, and also a nice perennial border here. But often they're very low diversity. There isn't much in terms of stratification or higher species diversity. And also they're not filling in the holes that some of these shrubs die, they're leaving spaces that could be occupied by weeds fairly quickly. So one of our recommendations was to, okay, let's try to experiment more vegetation layers, try a ground cover, such as thyme instead of or after wood chips. Talk to residents about what they would like to see in these in terms of plants. Go back and fill up the holes if plants don't survive, because it really can degrade and also have a lot of more problems maintaining weeds. So if we look at one of the criteria we looked at, does it cover, the plant cover really fill the space up? And for the most case, it was pretty good. At the end of the season, we had 65 to 100% ground cover. So the plants chosen did cover the soil pretty well by the end of the season. We looked at a couple of points during the season, and that's one of the good examples on Rue Turnbull. There were some infrastructures such as here that had put in a turf cover, put in a bit of plant, shrub cover, but because maybe it wasn't well designed for the neighborhood, or that wasn't discussed with the neighborhood, it's just been degraded. And so there's a lot of effort has been wasted in trying to put in a nice little green island, which hasn't performed. So you need to go back and rethink this. And that was what we met and talk to the people around. What could we do? Maybe put in a little some shrubs here to block all the traffic across the green turf. There are different things that could be done to try to help this, but go back and repair. And this is another example. Sometimes there was soil erosion, mortality of trees. And this was one where we found when we checked the soil texture, there was a higher silt content than normal. It didn't meet the norms. It was higher than it should have been. And silt has a tendency to erode. And so there were several trees that were dying. There needs to be repairs to the perennial vegetation. If not, it's going to look like this. Trees are gone. There are weeds coming in. So if you're going to invest all of this effort and money into the green infrastructure, go back and maintain and repair. Don't just go on to the new ones and keep multiplying. Look back, and that was what the city did in this case. So I was glad to take part in that effort and see what went wrong and what was right. So after these evaluations that we did, we were asked by the city to conceive some new cells, vegetation cells, and to work also on one of the new green streets that they were developing in areas such as Vanier, if you know the neighborhood, which has very low tree cover and low green infrastructure. So we did this according to our principles as LIEU. We went and we suggested complex stratification with one tree, Gladitia, that fixes nitrogen, 2 shrubs, 2 perennials, and a ground cover thyme. And this in order to have nice blocks of vegetation that have a nice massive effect, and also to have flowering throughout the whole season. They're starting with aronia, then rosa, then milkweed, butterfly weed, echinacea at the end, and thyme in the main growing season. So you have this nice continuous flowering and dominantly indigenous plants. Our principles try to have a really quick ground cover, so fast growing, long flowering period, adapted to the zone, accent on indigenous plants, plants that can adapt to the stresses that are particular to the urban system, dryness, salt, temperature variation. And this, we did a lot of work with, in each case, Montreal and Quebec, to work with the horticultural agents to pick out the good plants. Some that we suggested, they said no. And so we were quite happy to acquiesce to their suggestions. Also have lower maintenance if possible, an interesting aesthetic and interest for ecology, both fixing nitrogen, pollinators, and can repropagate by seeds or by vegetation propagation. So, and this was the street. We also did the same principles to have a nice plan for a street where they were planting trees all along the street beside a school, also adding trees for the residences along the street, putting in a whole two lines of vegetation, one for quickly draining water beside the sidewalks, and also another strip under the trees that were planted, which we worked on. So create mixes that are adapted to this, have a stratification as we suggested. And one thing that we noted from our past work, try to have a good volume of plants, like shrubs that have a really good volume. The more volume the more there is a cooling effect. That's what we found in Montreal. If you don't have this nice volume, there's less transpiration, evapotranspiration, there's less cooling. We measured these under different conditions, and it was really the biomass that had a more cooling effect. And so that was one of our recommendations. And then this last summer, again, we have both for Montreal and Quebec proposed these criteria and indicators for a wide variety of infrastructure that has been implanted in both cities. And we did evaluations. We had 2 landscape architects go out, 2 very experienced persons go and evaluate about 9 or 10 in Quebec and more than 40 in Montreal, according to these criteria. Are there presence of weeds? Is the soil covered by the vegetation quickly during the growing season? Is there wood chips and have they been eroded? Has the mineral soil been eroded? What is the number of species? Is there flowering fairly continuous? What is the aesthetic effect? Is there a nice form, texture, dynamic in the plants that have been proposed? So we did this across many, and this was actually the same street that we had designed, Champagnat, which is in Vanier, with, when you look to the left, are the draining vegetation layer, the cells that will quickly capture water. And this was Guillaume Gregoire and colleagues in Université Laval that did this design. And we designed to the right on the picture, the understory of the trees and the projected plant beds at the corners of the streets so that you can see right in the foreground. And some other photos of the same in the middle of the season. So you can see it's really nicely developed in all cases, both left and right. And to the left, you can see the projections at the end of the street, which again are well covered in the first season by the plant cover. A nice development. one of the debates going on in Quebec City, at least right now, is we are a snow city. And these street projections that slow traffic, yes, and allow tree planting makes it more difficult to take out snow in the areas where you can see the cars are parked. So this has been a bit of a headache, but it's not, the answers to increased vegetation and tree cover are not, there aren't a huge number of options, but I know it's one of the things that will be discussed in the next couple of years. So again, the same street, Rue Champagnat, you can see the nice cover under the trees that have been planted on the left. So it looks nice, but we'll have to follow up, of course, over the next few growing seasons. How do these develop? How do they survive? How do they look after 4 or 5 years? Is it still going to be so nice? And this is one of the evaluations that we did in a smaller tree pit at the corner of Bocage and Prue in Vanier again. What we used in this smaller pit was a ground cover of clover, which not all people agree with. Then there's Rudbeckia, Echinacea. We used a nitrogen fixing shrub, which is a natural shrub in Quebec, Clantonia peregrina, Cantoni, and Celtis occidentis, or hackberry, which is a bit out of its zone, which is interesting because often we'll plant trees a little bit out of their zone in cities which are warmer than the natural forest. So when Michel did this evaluation, he said, number one, for weeds, there weren't weeds, almost 100% cover at the end of the season, and partly because of the clover cover. A bit of the wood chips were evident, but no erosion of wood chips or soil. Not a high number of species, but in these small pits, you don't want to put in a huge mix of species. You just want to have these nice blocks. But we have the strats, we have thyme, we have trèfle clover as a ground cover, and then arbuste, a shrub, perennials, and the tree. And good medium, he said, for the longer term, the flowering throughout the season, and medium for the aesthetic appearance. This is another one he looked at on Route d'Église, which is older. It was more like 3 or 4 years. Really nice development that you can see associated with the trees. The problem places are, like I said, when you're in the middle of a boulevard or you have asphalt on both sides, it's really a stressful condition. There's going to be salt all winter on both sides, and you can see that there are a lot of holes in the vegetation to the right. So they haven't, again, the plants haven't been replaced. Should they have been by the contractor or the city? I don't know. One of them should eventually replace. Otherwise, these become weed attractors, and it will really start to degrade in a few years if you don't fill up these holes. So another observation. I thought I'd just talk a few minutes about strategies people have had for putting together species, the complementarity of species in these horticultural combinations. And one of several people have suggested in the literature the last few years using Grimes' CSR approach, which is using a combination of competitive, stress tolerator plants and ruderal plants. So ones that are fairly aggressive, ones that can maintain despite stresses, and ones that come in if there are disturbances. So I took a little course lately too with someone who's done a lot of work in prairie vegetation, Benjamin Vogt, who has a book called Prairie Up. And he suggests this too. He hasn't experimented with a lot, but he thinks it's an interesting approach to assemble a community, either to replace your front lawn or for urban horticultural infrastructures. But the constraint is that you really have to know how your species behave. And a lot of people don't have this knowledge. You can try to look up this information and you can find it in different books, in different places online, but you have to spend the time really trying to understand where your plants fit on this triangle. Are they competitive, ruderal, stress tolerators, and how they should fit together. This is one of his examples that he used for his prairie communities. To look at the CSR, in this case, oligoneuron was sort of a in-between competitive and stress tolerator. He then has a sociability index on how it behaves over time. Does it stay in a clump by itself? Does it spread, but not too aggressively? Is it aggressive, but it won't take over, or is it could take over if you let it go? I kind of really like this sociability index that he developed. And how is it going to last? And this is quite important for urban. And again, you have to kind of really take a look in literature and to try to find how long is this particular species going to last. In this case, he said 10 years about. So you kind of put this information together. How high is it going to become? Is it going to stay in a small group? And then he suggests it's a good one for all of these reasons. It's not as aggressive as, and I can vouch for that, Solidago canadensis, which I'm really going to, in my prairie on campus, have to control much more because it could just completely take over. It's really nice to have in the fall for the pollinators, but it would just love to take over the whole prairie. So this is a bit wordy. I want the main idea in this is he kind of recommends to have a combination of plants with different survival strategies. If you have too many competitors, they're all just going to try to dominate, and maybe one will eventually dominate, as the Solidago is trying. But if you have a combination with some stress tolerators, which normally will just maintain really nicely over time, or ruderals that will come in if there's some disturbance. And ruderals are nice, they'll stay for a couple of years, supply some color for 2-3 years, and then they'll go out, and you can always disturb yourself if you want to add some more color or a different color over time. So I like this. He said it's really hard to find the sweet spot of combinations of plants that will maintain a certain equilibrium over time. And I agree, I can see that our plant prairie on campus, it's a bit different every year, a bit different according to the moisture, the precipitation that year. And some are just starting to take over and others are starting to disappear a bit. So I have to keep, if you turn your lawn into a prairie, you have to keep this in mind and you have to keep playing with it. Our final recommendations from all of these projects, just look what I'm doing for time. Increase the number of species, use indigenous species, maybe, but we haven't validated yet, more plants that fix nitrogen. Try cover soils other than just wood chips because they seem to be generating emissions. Also, we need to follow up on how emissions are being produced in these tree pits, and we will do that. We need to validate with the cities what is the contractor delivering. In the case of Quebec City, everything seemed pretty good. Everything was pretty much in the same norm, within the norms, except for a couple of outliers. In Montreal, it was much more variable, and the horticultural agents were complaining about what was being delivered. Let's try to experiment with biochar or other alternative substrates to peat. And the reasons for that for people who restore are obvious. So, and people are working on this, but Well, can we use more compost? Can we use biochar? What can we do? Michel Fontaine, because he's a landscape architect, had these things to say about the more aesthetic appearance and combining plants, used big blocks of plants and not mixing a lot of plants. If you're going to increase species number, increase it in big blocks, but not in putting the plants together directly. Because these blocks are much more visible, especially along a street where you're often on a bike or you're in a car, you don't see plants that are mixed in with each other. You see these blocks. And some of them, like with the grasses, look quite beautiful in midsummer with these different textures or different colors, and have different heights. This gives a nice dynamic and a nice form, different textures. Same for shrubs, vary the height, vary the texture to give a nice form. We haven't finished with the draining infrastructures in Montreal. We'll do this in the spring. We're just, in fact, a report's going just be in the next couple of weeks. Here you can see that it's quite different. You can see gravel, you can see beach stones being used, and the plants are quite different. But again, a lot of the people in Montreal were noticing that the soil being delivered was maybe not what was required. If it's too draining in these, the plants that are like the calyxes that are planted may not have enough moisture. So there are a lot of things to think about in the next few months to develop guidelines. Just a final message about trying to increase what we measure. We can't expect cities to measure emissions regularly on a normal basis, but we are trying to, with these new projects, measure losses of carbon, measure methane, measure water infiltration under different conditions with biochar, with different textural layers. So we'll be doing this over the next 2-3 years, looking at how these different constructed soils might help in terms of emissions and water conservation. And these are the people, Shital and Tommy, who will be working with us. So finalize that and some perspective from what I presented. We want to propose a guide for best practices based on what we've seen. In the last 5-10 years, there are a lot more people working in urban context. And so this is great. We'll have more science to underlie the decisions on green infrastructure. In Montreal, for example, there was a lot of variable management going on, and we need maybe a more uniform approach among the neighborhoods that's underlain by science, including performance indicators. But at the same time, in parallel, we need to test new things. That's what scientists are for. Demonstrate techniques that could help to reduce emissions, increase fertility, aid water conservation. This is going to be big in the next few years. And we need much more attention to the soil, including a follow-up of texture that's used. How can we reduce organic soil inputs? We need to work on this. And again, there are a lot of scientists doing that, but we don't have a solution at the moment. So thanks. And I'll be happy to answer any questions.
Alors, merci beaucoup, Alison, pour vraiment là, ce webinaire très intéressant, mais qui apporte aussi beaucoup de points à réfléchir, à prendre en considération dans ces aménagements urbains-là. Personnellement, en tout cas, moi, la profession des horticulteurs urbains, je vais voir ça avec une toute nouvelle vision de leur profession. Ils ont beaucoup de choses à prendre en compte, puis on peut passer beaucoup plus maintenant à tout ce qu'ils doivent réfléchir durant l'hiver pour préparer les plantations au printemps. Fait que je te remercie pour ça. Est-ce que, bon, j'invite les questions là, de...
I see there's a few in the chat. Dead leaves. Yes, Joelle. Actually, we experimented that in Montreal, leaving the plants over the fall instead of cleaning it up. And I see that there are a few places in Quebec also that they seem to be doing that. Maybe they're testing it. And instead of cleaning everything in the fall quickly and having nothing left as a cover, because I think that's good for both erosion and for the return of nutrients. The cities are less, not so enthusiastic yet, I think, because residents sometimes complain, oh, it looks bad on beside a city street to leave litter, to leave stems. They want it looking neat, but I think we have to think in the long term and gradually try to get a better social acceptance or try to get people used to a more natural approach to vegetation. So yeah, it's a great question. Conversion of zones.
Pierre Cartier
Pierre?
est présent, il pourrait peut-être directement poser la question échangée. J'invite Pierre à...
I can try to translate my questions from French to English also. All your examples were more like new sites where they created something. Do you know examples from where we can convert area that are grass to, let's say, microforest or something different?
Yes, we have worked on that as well. One of our first projects was on a lawn at a hospital in Hochelaga, where you can still go see our plots. I'm just trying to think of the hospital. I can send it. But they changed, they let the grass grow, and now they have big islands of prairie that came back naturally once they let the grass grow. At the beginning, we also had plots with some green manures, such as ryegrass or others that can look really nice for a season as you're implanting, and then you can overseed what you might want to put on the, we found that overseeding was better than taking off the turf and starting from scratch. So just overseeding and seeing how that goes for a few years. And you can always intervene and re-overseed if necessary. And sometimes what I see from the people who are really working on prairies in the Midwest and mimicking prairies on front lawns is that they play with it a bit. It might take some maintaining over time, not if you want to have color, if you want to have some certain species, you kind of have to work at it, but it's certainly possible. And there's some beautiful examples with, say, Benjamin Vogt that I mentioned with his Prairie Up book or others. He also has a book, The Ethics of New Gardening, or The New Ethics of Gardening. And he has some great examples of these. And people that are restoring prairies in the Midwest too, that were actual prairie vegetation before. So there are a lot of good examples. And yes, it's certainly possible, and with some really nice results.
Excellent.
Merci.
On a une question ici de Daniel Alexandre.
Oui, merci. Donc, je vais la poser en anglais. Donc, je m'appelle Daniel. Je suis un ecological restorationist. I just wanted to know what kind of comments did you get from the horticulturist? So when they said that, no, we don't want to have this kind of plant or that kind of plant, what kind of plants were declined and what reasons were given for that, just in a general sense?
Yeah, they had a good, the people that work with the cities as horticultural agents have a really good idea of, like I was talking about, the behavior of certain plants. So when we suggested certain plants that are really robust, that are stress tolerators, they said, yeah, but by the end of the season, they fall over, they fall into the street, they don't look good, and we get complaints from residents that, it's kind of messy. So they were concerned right away about how it's going to look over the whole growing season. And even though it might look really nice in July, you know, by the end of the season, it's one that people could complain about. So we listened to them on that, and we really took out plants that they considered to be not well behaved. So, and even some of the ones that we tested that we thought could be good, such as chicory, again, by the end of the season, it wasn't looking great. So we might not, and for small, let's say small tree pits, might not recommend it because it tends to produce really nice flowers through July, and then it starts to fall apart and fall onto the street. So a lot of things about behavior we listened to, and some they knew more about their resistance to salt, for example, than we did. We looked up a lot of things from, say, the Minister of Transport that has a good guide about what plants are stress tolerators to salt, but some of them along streets were not particularly good. So it was great. It was a great conversation. We learned a lot from them. In fact, and in both cases, you know, we generally didn't go against their wishes. One thing in Quebec, it was more difficult to convince to try seeding because they weren't convinced directly seeding, and so we didn't directly seed. They said, oh, but it's more difficult to find seed, which we weren't convinced. But again, they did in some places try the seeding, for example, the clover. And I'm going to go out and look next year how those ones that we did seed, how they look.
Thank you. Thank you very much. So maybe, Alison, when we will put the PowerPoint or the video conference on the website, there's somebody that is asking if you could recommend literature about estimating plant sociability of index of species. So I will let you with that. So maybe I could take one last question, if somebody has one last question, to just make sure we keep in time. So you've been talking, and just the last one then, several times about replacing up to use wood chip because it decomposes, create the greenhouse gases and all that. What were your best replacement that you are suggesting then?
We tried ground covers, for example, clover, and also thyme in Montreal, which makes a nice fragrant cover and spreads quite quickly. Again, we have to see how it endures over time, though I've seen some sites that seem to have been in thyme for a long time that look really nice. So no, but we have to follow our own sites and see over time how that endures. So yeah. The Prairie book I mentioned, there are two by Benjamin Vogt, V-O-G-T. Prairie Up is one, and then A New Ethics of Gardening is a second. He has two books out. Prairie Up is more practical tools. The other one is more philosophical, The New Ethic. Yeah, he has thought a lot about these questions. I really like his approach. There's other places like Prairie Moon Nursery in the Midwest that also has done a lot of thinking along these lines.
Excellent. Okay, so I thank you